Good morning, gang.
Mm.
Good morning, good day, good evening, depending on the time zone.
Exactly. We have a global team, so we'll probably cover everything. Do we have every continent represented? North America here,
Sweden, Nordics.
Europe. Welcome, Nazar.
Asia.
Asia. Awesome.
Some
Any,
from Australia and Africa, I suppose,
yeah,
and
it'd be
South
great.
America.
Yeah, those three. And you never know, we might even get Antarctica and Arctic circle. That does happen. All right. So you guys are stuck with me today. I have no idea what I'm doing. Santiago, whenever you're ready, we can kick it off.
Yeah, I don't know. It's 2 minutes, but it's okay. We can kick it off. So today, Mash, will be our lecturer or volunteer for specifically chapter 2. The idea is that he will cover chapter 2 ideally in detail. We will ask questions, we will participate, engage out loud if you want, or in the chat. My task for the day will be focusing on the chat. I'll try to, if there's like someone asks a question that is relevant to the things that Mash is saying, or somebody is asking as well, uh, I'll try to just interrupt and ask the question out loud as well. And I'll also keep an eye on open mics. Uh, so we have a calm session. And what else? I also would like to, at the end, cover a little bit one of the notebooks of the bonus materials that Sebastian did that is in his rep. So that's basically it. And one of the objectives of for the end of the session is also to see if somebody wants to volunteer to do the same as Mash is gonna do today, but for chapter 3. So just keep an eye if you would like to do it next week. Right.
Thank you, Santiago. So I'm going to reiterate a couple of key points that Santiago mentioned, which is uh, we're going to, in terms of timing, Naveen mentioned on, and hey, Naveen, as you mentioned on the Discord channel, there is a lot of ground that we need to cover. I will try to get us through it quickly. I need your help to jump in, raise your hand, interrupt me at any point. This is a study group, so interruptions are actually welcome. Where you say this is not clear, and if I can't explain it, and again, I'm just the facilitator here. If I can't explain it well, somebody else jump in. Feel free to jump in again, interrupt as we go. It's a study group, so that we all come out of this with an intuition of the material. This part of the material, as you all know, is really important because we're going to bridge into attention mechanisms next in the next chapter. So this one's really key that we understand encodings and so on. There's one other reference that I may pull on that I haven't shared yet, but I shared the Financial Times sort of their visual aid that they use, which is really, really good. And there are, I'm sure you've all got your own favorite ones as well. So without any further ado, we'll jump right into this. And I'm going to cover, let me share my screen. Da, da, da. Oh, that's a new one. One moment, please. I'm seeing something really interesting with when I try to share screens with Zoom. Oh, here we go. It does have a count. Allow. Excuse me. I've got to give access to on a Mac. Um, I'm gonna need to quit Zoom and come right back. Excuse me.
Oops.
I
Yeah.
have just
Yeah.
an out of context question, like it's not yet relevant to this, but I have a question that is anyone doing PhD or has done PhD from the United States or UK. Um, like if there's anyone who has done it, obviously in machine learning AI related field, like if anyone has done, I would love to connect with that person. Thank you.
Not me, but maybe you can ask in Discord. Maybe there's someone that is not joined.
Yeah.
What did I miss?
I was
Um,
asking that whether anyone has done PhD or is in the process of doing PhD from United States or UK. I mean Europe in general. Uh, Nothing.
mhm.
Nothing. Yeah, we can proceed.
Okay, okay, no worries. All right, so here's what I've got. I think I kind of mentioned earlier last week, the way I'm falling on to what worked for me in the past. Split screen, code notebooks uh, on one side and the book on the other. Uh, I hope this is legible for everyone, uh, where you can see the images and everything else and just the code. We'll There is no need to run this on a GPU instance at this point because we're doing basic encoding even with one small file. You can use the Edith Wharton book. I've got another text file of all of Shakespeare's works, uh, which also, that's not very large either when you think about in the scheme of things nowadays, and that runs just as fast on a regular good computer as well. So we don't need a GPU for this. What's really important is just getting a solid intuition for just encoding in general in order to get us ready to understand transformer architecture. So let's get right to it. The first initial bits we're going to breeze through quickly. At this point, I am quite confident that everybody here understands why we tokenize text. Computers are really good at just computing numerically. The whole point of GPUs is to be able to do matrix multiplication, that linear algebra. So how do you take any kind of multimodal content, whether that be text, whether that be images, whether that be videos, spreadsheets, whatever kinds of content you want, turn that into some sort of a matrix form. That's the encoding aspect of it, so that we can do the necessary steps of transformation in order to then allow the deep learning neural network function to work. I'm going to stop. We don't need to dig any further than that at this point, just for this. So as you can see, Sebastian uses his favorite example file, which is the Edith Wharton book, uh, and shows first, here's text. You want to try to turn that in the first step is turn it into separate words in order to get into a vector. Uses regular.
Yes.
Go ahead.
Someone asked if you're sharing the right screen, because right now we see YouTube and I think the Discord, but I don't know if you're also.
I am probably, then maybe I'm not sharing the right screen. You see YouTube. Okay. All right.
Mhm.
Gosh darn. All right. Please let me know.
Okay, okay. Yeah, now it makes sense based on what you were saying.
Okay. God, you gotta hate Zoom. I just updated Zoom and I had to give it new permissions and so on. And I promise you, it said this was screen 3 for me. Whatever. All right. So, really quickly, book to the left, code to the right, and as we get through it, we're using. He splits the words, basic
Mhm.
regular expressions, still very, very important. Me, 30 years in, where you'd start dropping out empty spaces, et cetera, to pre-process it. And then the whole point of it is you're taking every single unique word, mapping it to a number in order to be able to get it into a vector. Now, as we do this, what is we can, I don't want to belabor this point. He's built simple tokenizers to be able to take specific words, encode into that number, get to a matrix, plays, encoding, decoding over and over again. So you guys get what that point is. And then, of course, the notions around beginning of sequence, end of sequence, padding, because when you're taking matrix multiplication, it has to be the same size vectors. So if you're putting in different types of sequences, they're not going to be the same length or so on. So you want to pad it. They're unknown. There's an unknown tag to represent words that are not in the vocabulary. But eventually you get to a point where you've thought through everything and everything is in a standard form. For that standard form, that tokenizer to use, there are a few out there. The one that he actually did a test on was the one from OpenAI, TikTokin, the newest version. I do urge you play around with TikTokin's repo from OpenAI on GitHub, and it provides all sorts of really interesting information on how to use the TikTokin library, as uh, Sebastian even mentions at one point somewhere, whether it be one of his blogs or something. Uh, the TikTokin library from his test is 6 times faster in tokenizing than the next best alternative. I think Hugging Face has one, and so on. It does all the byte pair encodings, etc. So what you're looking at is this is a notebook from OpenAI among many that they've got on their GitHub repo. Again, I cannot stress enough, play around and check out OpenAI's repo. And they do pretty much the same thing of here's how you compare and do the encoding, decoding, compare it, and so on. This particular function that they've implemented says, here's how you use TikTok and to even count the number of tokens that you're inputting and taking out. For some of us applied folks, we need this when we're trying to assess if you're going to put, tens of thousands of documents through and you're pre-processing, fine-tuning, building models, building applications, we're going to need to know the cost of the tokens input, output, all of that as part of performance and everything else. As you
Sorry
can
to
see,
interrupt. I have a question.
yeah.
Seeing the compare embeddings here, right? So it's 2 plus 2 equals to 4. But then when we see the embeddings, we notice, sorry, when we see the characters itself, there is
Mhm.
like the space which is part of the character. If you see like 2
Mhm.
and the second one is space
Mhm.
and then plus in the token. I'm not sure why the space needs to be present for the plus, because it should just be 2 and then in the so if you take R50 base
Mhm.
in the output,
Mhm.
yeah, so the individual token bytes, it's 2 followed by the next one is plus followed by space followed by a plus. So I'm not sure why the tokens have space included in them. Shouldn't they strip away the space characters?
So what I've jumped to, really good question, Ganesh. Thank you for that. I've jumped ahead. What you're referring to is the basic understanding of when you're putting in a string and you're doing the encodings, you've got a lot of these empty spaces in the string. And so how do you take care of that? How do you pre-process with that? So as Sebastian explains, that's why he uses the regular expressions. You remove the spaces and so on in his simplified example. But in a much grander level, um, when you're trying to do the actual formal tokenization using tools like TikToken, they do indeed remove the spaces, as you rightfully pointed out. Why do you need it? You don't need it. But as you can see, what it over here, what it's trying to do in a formal implementation of tick token, it is sequencing them out as the space, this bit to space. Compare that with in different strides of 2 plus space. Then again, 2 space again, because when you're sequencing out them out that way, there is information there. And all you're trying to do is really understand not the arithmetic calculation, but you're trying to understand this string 2 space plus space 2 plus space equals space 4. Because you're trying to do that, you're going to put them into a whole sequence of that grander matrix. Going back to how Sebastian tried to explain it, he's keeping it very simple. He's just saying, okay, I'm going to drop out the spaces. I'm going to simply take each unique character and so on. I'm going to encode them to a particular long list of numbers, and I'm going to create a vector that sort of like, a 4-year-old might convert words to numbers kind of approach. Create a vector that way. Team, does that, to everybody else, does that adequately explain or elaborate on the question that Ganesh asked?
Yes.
Okay.
I just want to clarify if I'm understood what you said with regards to the spacing. You basically told that removing the space is a simplistic way, but then when you add the space together, it provides it more context of what the entire operation is trying to do together, as in a spatial context of sorts, right? Did I understand it correctly?
That is correct. That is correct.
Okay.
And that's why the parameter stride also matters. So sometimes you'll use strides of 4 or so on. Like that's the big chunks of which will include the space in there. So there you need a representation of that space as well.
Mhm.
Thank you very much.
Just that they're also maybe not exactly related to space, but I remember I don't know if you played with NLP before the whole LLM boom. We used to lowercase all the text and remove like stop words and stuff like that. And nowadays it's like, oh no, actually that's actually helpful. Like we actually care about capital letters. We care about stop words that are like there because they give some context. They help LLMs to sound like a real human and not like a machine. And it's because before we were not using LLMs because they didn't exist, but we were not using NLP tools to generate text. So we didn't want them to, or we weren't using them to only generate text. We were using them to, I don't know, do text classification or sentiment analysis. So you wanted to do like this feature engineering and take only the important stuff in sentences. But nowadays we actually care about spaces, about stop words, about capital letters and stuff like that.
Exactly as Santiago said. Before with NLP, we were just predicting. And we weren't and we at most wanted to predict something out of that NLP, whether that be a categorization or something. With LLMs and just playing with language, even as we've built this out right now, this is applicable for us. You look at that sequence, everything in blue, and you try to predict the next word that comes after. Now, the spaces and the stop words and all aren't quite as relevant. As you can see, there's no predict space, but you are predicting the next best word. And for each of this, there is a probability. I think you saw in the Financial Times, like they used interest rate in two different parts of a sentence, and where in that sentence the understanding of the word interest as in I'm keen to understand, something I'm interested in, versus interest as an interest rate, that there's different probability weights to it, and that goes into the sequencing of it. All of that matters. We are simplifying in how we look at it, but all of that to put it together is going to be key. Ganesh, does that help?
Yes, yeah, it's clearer now. Thank you.
Yeah. But hopefully it actually makes it even more complicated, because now, as you begin to do this, you're going to get into different ways of, like, okay, specifically, how are you encoding it? What are some of the options you have on how you encode it? This is where TikTok and package. You can use lots of other packages too. You can use the one from Hugging Face. You can use others that people built themselves. And I presume, I don't know this for a fact, but if you're a different AI company, maybe your approach is using an entirely different encoder that you've designed. You just believe that works better, is more performant. That may be the case. For TikTok in, there are different parameters. As I said, take a look at what's available in terms of encoding, decoding methods, and so on. So if you were to take, for instance, here's one where I'll just take the tokenizer and I'm going to put just a bunch of gibberish, okay? And it still decodes it. Now, if I were to take this same thing and try to encodes it and breaks it down. But if I were to try to do it this way, what did I do? Oops, don't need that. And it will still manage to decode it right back. Even though this is gibberish, because what it's doing is it's trying to break out this gibberish string into constituent numerical values as part from that standard indexed table that it has. All right. So moving on, he starts playing with, like, okay, well, use that byte pair encoding. Um, this was, did everybody understand byte pair encoding?
Okay, yeah, I would prefer if we can go through that.
Sure. So
I can just share my understanding in the understanding from the point of group coming together. Uh, the whole point is that there's only so much that you can take up a text like a book and assume that it will cover all the words there. So, for example, in this text, the word like hello was not there. Okay, so how do you then figure out a token for the word hello? So what byte pair encoding does, as I understood from the text, is that it takes up words but also breaks them. That's why I think it's looking at it's calling as byte there, and then looks at in terms of, let's say, if there's a word, let's say like international, so it'll break up the word into international there, and look at so it breaks into subunits there, and then makes up like a dictionary of those subunits there. So then it has a lot more tokens at the individual subunit level and there, and then words which are combinations of those. For example, let's say inter or national. Could be separate words, but because it has those subunits, it can actually combine them and to create the word there. So in essence, it has a much more discretized dictionary, which is using to combine the words and create the tokens. That's the essence what I understood. I'd be glad if anyone else can add on to it or any nuance that I missed.
Yeah. A question, is this based as well on the frequency? How often does this kind of come together in this specific token? Because I think that was something mentioned in the book around that. But what is exactly the formula behind byte pair encoding?
What's exactly the formula behind byte pair encoding? I mean, I used libraries earlier, so I'm not sure of the formula. Then I'm assuming if they would borrow from language, it's good to look that up, yeah. But assuming they would use a mix of language, because a lot of languages are, I mean, the subunits are kind of common. Let's say discussed, this is a common prefix or suffix that's there here from the world of NLP, and probably Santiago can chime in. In there are a lot of prefixes and suffixes that are already understood, that they give us a meaning. So probably use those and then use a corpus and analysis of corpus, what kind of subunits are there, and probably create that. At least that's the way I used quite some time back. I used a library, but yeah, anyone else can chime in if they have actually figured out the byte pair and coding formula. Yeah.
So live coding, I took exactly what Naveen said, the word internationalization. When I encoded that, you get this sequence of two numbers, and then you decode just that sequence of two numbers randomly. It brings it back as internationalization.
What
If we
happens?
were, go ahead.
What happens if the code only the first number? Like let's go to the lower cell.
Okay.
And the code, delete that one. Just to see if it is international. Okay, cool.
So
And
now, go
and
ahead.
then go again to encoding. To encode,
Tell me.
and encode international. I want to see if it is if it is okay. Yeah, that makes sense.
Yeah.
Cool.
Which is interesting. How about if I were to remove that? Look at
And now write maybe another word that ends with that. I don't know, like commercialization. I don't know. Any word that,
Realization.
yeah. Just to see if we see 1634.
Yep.
That is my understanding is that it is based on the how common, like how many times this token appears, like isation. And I still like don't fully grasp everything because from what I read is that there is like this threshold of, okay, if we see this token that many times, it is gonna be itself like its own thing, like isation, like it appears that many times that we don't need to break it into Isa and Xion. I don't know. This thresholding, I don't know if it is optimized when building the tokenizer, or that part is the one that I don't fully grasp. Like, is this like a hyperparameter that was done once they developed this tokenizer, or is
I
is
have a
something
question
that go
additional
ahead.
to this. So basically, that means that it's iterating in the algorithm in some sort of like n-grams by like expanding and looking up the matches, right? Okay.
Yeah, 100%. 100%. And because of that matching, that lookup table absolutely needs to be a standard. So OpenAI, it makes sense for OpenAI to come out and open source their TikToken package that's got its built-in lookup table as comprehensive as they wanted, because the more people use it, the more easier it is to implement OpenAI's tools downstream by other companies, because at some point they're going to have to do this. They're not going to run everything through their context, and you want an application to do some of this encoding, decoding of massive amounts of content on their servers. Let them pay for it before they pass it on to OpenAI, which will also have a limited infrastructure constraints. Hope that helps.
Yeah,
Just
someone
to,
share.
sorry, just to add to that here. So I took a look into the token package basically, and you're right, Mashruk, like it's like a gigantic dictionary with like every key value pair. But Nazaria asked this interesting question about how this chunking works, right? So apparently they use greedy algorithms to kind of
Yeah.
what they do is it's like they locally solve a problem, hoping that it would solve like a bigger problem. So um, in the text that you've shared in the book there, the one with AK. So essentially, what happens is it's looking for those first two words. If it can, sorry, first two letters of the word. If it can find a match, it would just say, "Yes, I found something," and then it goes on.
Right.
Yeah, so you see that AKWIR, that's the one. Yeah, so it locally like solves that problem, and then it keeps moving on to the next one. Yeah.
Yeah.
Thank you.
That's a really good. That greedy approach is important.
I wanted to just clarify regarding what Santiago said. So he says that the hyperparameter is to decide how many times the subword appears, right? I from what I understood, it is that the hyperparameter is set for how many unique tokens we want and not the other way around. I just want to clarify if someone has an understanding of which of the two it is. Like, does the hyperparameter decide the vocabulary size or how many times a certain uh, character or a set of characters have to appear before it's considered a, a certain token, individual token by itself?
Does anybody have an answer to that question? I don't know the exact answer off the top of my head, Ganesh. So I'm looking for it right now in the OpenAI cookbook for TikTok, and I know it's here somewhere. But if anybody has,
And someone shared here in the chat the algorithm from what it looks like a paper. I don't know if you want to share it. Mash is in the chat. It's like an image. I don't know if it is easy to find. But yeah, at least from what we can see in this, there. But from what we can see there, the hyperparameter that I see in this example, it's a number of mergers. Like that's the only thing that they actually specify in below. So yeah, maybe I don't know what's the question, but yeah, maybe that's the right intuition instead of like the threshold that I was mentioning.
Yeah, and just to reiterate my understanding, I'm just using ChatGPT for the formula. The more than formula is more like an iteration, as I'm understanding. So if there are words like low, lower, lowest, it will see which pair, let's say L and O, which pair is the highest frequency, and pulls them up and gives it a subunit status. And then like that, you keep going through all the words and see which pairs are the most common and creates a dictionary of those pairs. That's what seems to be coming across there through the iteration. And then basically one can choose at what when do you want to stop it, what vocabulary size you would want it. Then
Sounds like a nice homework to do.
Yeah, looks like.
And it's not, you can say you are using a standard approach, just as Hugging Face, someone shared this on the chat. Hugging Face uses this implementation for byte pair encoding, and this is their standard, but OpenAI might choose a slightly different standard to byte pair encoding. So it is hard work, but it also needs to be standard way in order for everyone to be able to get the same output. But again, companies compete with one another. They'll say our approach is better. Any other questions before we move on? Don't want to belabor this particular point.
When we talk about good or better, which metrics do you consider?
Good question. I don't know. Does anybody know that? When we say good or better, my intuition, I'll just say this much. It all goes to ultimately the performance is going to be your final output. So if your final output, when you're using this approach for encoding, decoding, and then it goes into your model and the model outputs something, if that is good enough, like it's competitively, you say, oh, I asked a question and it gave me generated a response, and that response I feel is better. It could be something like that. Anybody have better understanding or intuition?
If you scroll up a bit, there was a mention about where do Hugging Face stop. So right here, no, down. It's mentioning the 40,000. So a bit down, yeah. So this is their kind of feels like parameters set. Where do they think this is reasonable?
Yeah. Yeah, they said, okay, 40,000 mergers. That's our limit. Because let's think about it a bit. If we only do, like, if extreme cases, if we do zero mergers, we end up with what? With all the just the single characters, right? Because we didn't do any mergers. We just have like A, B, C, D, and that's basically like the letters in the ABC. And if we do the other extreme, as many as mergers as we can, we end up with the complete words. So at the end, it's just the original text, right? It's just a dictionary, the vocabulary of the original text. So we need to balance this trade-off to something in between. So we have not complete words and not the base. And I guess this is the number that worked the best. And how did they decide it the best? Because they had some evaluation, like some evaluation methods. They had some benchmarks to run. That's,
Yeah.
high level understanding.
And Eddie, I think it's your point. You really were asking, well, what is that evaluation benchmark? And I think it's discretionary to the company that's putting it together.
Yeah, there are some open source evaluation benchmarks, but probably they also have their internal ones that can be like a many different tasks: question answering, summarization, translation, etc. Carlos, I see Carlos hands is raised.
Hi, Carlos. Go ahead. Carlos, you're still muted if you're talking.
Yeah.
Carlos, do you want to come off mute?
Maybe his mic is not working.
It said in the chat that host does not let me unmute myself.
Ask to mute. I don't know why.
I don't have host privileges, so
Yeah, I do, but I only see the option to ask Carlos to unmute. But I don't know what
okay.
is happening.
He'll come back on.
Yeah.
We'll remember to come back to Carlos. All right. Let's move on. Go back to my code. By the way, if you guys aren't using Cursor, it is the best implementation IDE I have found. Way better than Visual Studio Code natively. All right, moving on. So I think we got the sense for for that encoding and then like laying it out, where in these chunks, with that what he calls a sliding window, where you're just sort of trying to predict the next best word and keep going from there, all in sequential order. And so finally, then he starts getting a little bit more serious. I watched one of Sebastian's own videos, the one he's got on his YouTube channel for the 3 hour training, and he breezed through this. He said, "Oh, this is going to take 4 hours to do," but I think this is a really important point. I wish, but and when I looked at other references that I trust and follow, they explain it in slightly different way. I think just reading the code and getting an intuition of the way that he's Sebastian has laid out how he does his data pre-processing here, I think is good enough to just get a good understanding of this. Um, Anybody have any points to add? All right. So really
Sorry,
quickly,
Mashruk, what is that picture trying to address? What is it trying to convey?
which
The one that you
This
mentioned, yeah, in the heart of the city. Basically, it's a tensor. I mean, basically, it's creating input and target, like a sliding window based input and target uh,
correct.
kind of table, fundamentally.
Indeed. So there was this image, was it right before?
Yeah. Mm.
Think of this, that input and target, it's you've got this first word, and
Yeah.
then predicting the next word after that. And
Then
so
each
now,
time
yeah. Mhm.
keep sliding. Got it. Got it. Yeah.
We're just trying to predict that. And that's what he's saying here. And this is only to give you an intuition. This is not how it's really done. How it's really
Mm.
done is, I think, does he have a image here? Yeah, this one, where you take big strides at a time, not one word at a time. Like here's one word, and then you kind of try to figure out the next. It's take chunks of like four for each stride, 4 words at a time. If you were to say, I take a stride of 8 words in one go,
Yeah.
now
Okay.
adding the probability of being able to get it right of what you predict the next time is going to be way lower. So you kind of have to go, okay, I don't want to do just predict one word at a time. I
Yeah.
want strides of 4 or 6. They figured
I get
out
it. This stride, I think it's done in convolutional neural networks. It's done, that way of stride, how you take pixels. I think it's the same concept of stride applied to text over here. Got it. Got it.
and everybody explains this differently. So this is how Sebastian tries to explain it. If you refer to the Financial Times visual aid, they
Hmm.
jump pretty much into, well, here's how the transformer architecture works. And that says, well, you've got this chunk in the middle, and it tries that whole attention mechanism, tries to understand everything around it, before it and after it.
Okay. Okay. So you're saying stride might mean different in an attention mechanism, because okay, when it comes to attention, then we probably cross the bridge there. And right now,
Yeah.
stride.
Well, I don't think it means anything different. I just think it means the same. It's just how you look at it in that approach.
Okay. Okay. Let me look at the Financial Times carefully. Yeah, and then we can discuss on Discord. Yeah. Yeah.
Yeah.
Please go ahead. Yeah.
So he creates this very simple data loader a function, and he tries to show like, okay, let's try to do this in batches. And as you can see, here's how it works. And all you're doing is taking all those batches and turning it into a matrix, a tensor. Once you have it as a tensor, now the whole point is once you get it to a tensor, you can do the computations that you need to do to get to the probabilities, the predictions, all of that. The final part is token embeddings. Up to this point, I think this part, so I wasn't keen on the way he just explained it. He just sort of laid it out there, and it just saying, you've converted it into a matrix, but then the whole point of doing these overall embeddings and so on is make it into a multidimensional matrix, right? And he tries to explain it where using this to say, well, think of the weights, refer to my other notebook where he actually tries to explain it really well in sort of how the embeddings are applied in that neural network functional structure. I think I get it. I got it. But when I tried to see how I could explain it really well to give you all a good intuition, all of my other references also sort of like poo-pooed it and said, yeah, just this is how it works. Move on. So unless you're coding it in Python, like from a blank screen and trying to do your own implementation, I think this approach is just accept this as this is the standard way of driving. Everybody follow the rules of the road. I hope that makes sense.
I'd like to try explaining it, perhaps.
Yes,
I'm
please.
not sure I have any particular expertise, but when you have a token ID, you can think of it as an identification, for example, of the word "the."
Mhm.
So that doesn't really tell you anything about the word "the." So, for example, you could have some additional information that's hard-coded initially that says, is it a noun? Is it an adjective? Is it a number? You could add that information, and that would add a lot. So nothing that we've done up till now has any actual information about the word except as a string of letters, for example. And so if you want to learn something about its meaning, where are you going to store that something about the meaning? For example, if it's an adjective or a noun. So there's no place to store it. You just have a token that doesn't have any meaning. It just allows you to recreate the original letters. So an embedding allows you to have a meaning associated with it. For example, noun, adjective. That's not the type of meaning that gets done. And so where's that meaning going to come from? So in a simple world, you could assign it, look up in a dictionary what the different type of, is it a noun, is it an adjective? And of course, in a deep learning world, instead you apply massive amounts of text and you learn what, in the context, each of these tokens actually means. And it's, I think the numbers are like 10,000 element long vectors is what you end up with. And if you just think of it as in 3-dimensional space instead of 10,000 dimensional space, words that have somewhat similar meaning. For example, the examples I remember seeing are king and queen. They end up close to each other in this multi-dimensional space. But that gets learned. That's one of the key things. It's learned from the training data. And so it's mentioned here that it's a learned, the embedding is learned.
Yeah.
That was
I think
a
I
great
use the same.
explanation.
Yeah, I use the similar materials because I recognize your examples. And the one thing I want to say is it's learning things such as we humans, we ordinary humans with our organic brains, use the noun, adjective, verb, and so on. The learning that it does is it begins to understand for itself, the algorithm, the rules of grammar. So this, and how all the words come together, which then, based on its probability weights of everything, and how from there it can start to construct what the subsequent words would be. Just building on what Peter said. I took a look at the chat, and this was an explanation, a diagram that someone used Claude to do, and put it into PlantUL or Mermaid. Or does anybody want to, Ganesh? Do you want to walk us through this?
Sure. Yeah. Actually, I didn't put it through Plantum. Like, it already shows the output through artifact. So I just like took a screenshot from it.
Oh,
Yeah.
cool.
Yeah.
Cool.
Okay. So this diagram basically explains how the embedding layer works equivalent to using a combination of linear layer followed by one-hot encoding. So to explain, let's say the reason we're using embedding layer is to do a lookup operation, right? So let's say we want to look up the word index of 2. That means the second token in the dictionary or in the vocabulary, you want to fetch the embedding value for it. So a lookup would just, you would just do weight of 2 and then like directly get the embedding of it. It's a simple lookup operation. Now Sebastian has a notebook explaining how you can equivalently implement the same thing using one-hot encoding, multiply that with a linear layer. The code, I think the diagram explains this in a much shorter way. So if it's word index of 2, that means it's the third position. So you first construct the one-hot encoding. So it's 0, 0, 1, 0, 0. Now you have your weight matrix, and that has basically, here it's 5 different tokens, right? Now you want the third one from it. Now take the, okay, so what, okay, how do I explain this? So when you do a matrix multiplication, what essentially happens is take the one-hot encoding and then turn it vertically and then slide it over the weight matrix. If you slide this, what's going to happen is the 1 will slide over E20, E21, and E22, essentially giving you that answer. So you have to, that's what the intuition for a matrix multiplication is. You take the encoding, turn it vertically, and slide it over the weight matrix. I'm not sure if that explains it well enough.
I
Sorry,
think that
where did this weight matrix come from? What's the how is it set up?
So we essentially have 2 different matrices. One is for the token embedding and the other is for the positional embedding, right? So the lookup is done for the token embedding. Actually, you could do it for, actually it's done for both, my bad. So you will essentially maintain 2 separate embedding matrices, right? So the weight matrix pertains to both the token embedding and the position embedding. So you want to look up the embedding value for it, right? Before you feed it to the transformer. Because let's say you have a sentence for each of the tokens, you want to get the respective embedding value and then pass it to the transformer.
Mm-hmm.
Yeah, and so you essentially have to look up the token's embedding value.
Okay, like that. Okay.
one more reference to try to use. Brandon Rohr, a buddy of mine, he's in Boston. He also did a whole bunch of teaching things, and as he tried to get into just transformers from scratch, and this is from 2017, I think. But in order to even get to it, you got to go right to the one hot encoding, and so he tries to explain it in his own way as well. Like I said, everybody has different ways of explaining it, and he tries to do that where he says, now you've put it into a matrix, then you do the dot product and the matrix multiplication with the probabilities and so on and so forth. Ultimately, you get to that whole notion of you're just doing a lookup, table lookup. That's all it is. And so then he starts getting a little bit more serious. And the reason why this thing works when you're doing all that matrix multiplication in order for the neural network functions is the Markov chain and the implementation of the Markov chain chaining process and so on. And then you get the whole sequence model. So I thought Brandon's explanation was pretty good, but again, at this point, he was just he goes very deep into this as well. While Sebastian just says, look, here's how you implement it in Python, accept it, move on. Anything, Santiago, do you want to add anything to that?
Yes, I have something, and it's related to the meaning aspect of the topic. I think this is the core. They say it's a core idea, the meaning, and there are also some studies in psychology which actually use large language models as tools within psychology. So for me, the way I understand these embeddings is to model the relative meaning of words. And I think if we think about this idea that relative meaning of words, that it makes a lot of sense, at least for me, that we have words which are semantically very similar, yeah, like king and queen, kingdom, yeah. So then you can represent these words using very similar vectors, very similar mathematical structures, because they are related. So basically, in my understanding, the embedding is a tool which is designed to model the relative meaning of the words, how words are closely related one to the other, not necessarily that a certain sequence of numbers can depict by itself an apple, for example. Yeah, but two different sequences of numbers can be very related if they describe two attributes of the apple, for example, apple and apple juice, for example. So, so this was my comment. That is embedding is used to model the relative meaning of words.
Yeah,
Meaning. Not the meaning
yeah.
per se, not the meaning, which is a deep, it's a deep philosophical enterprise. Yeah, to go to the meaning of the words, but to model the relative meaning of the words, can be done with using embeddings.
Yeah. And that's also my intuition of why is it like the reason why we create very high dimensional embeddings, to give us like this kind of flexibility to assign the meaning of a word in different contexts. So because if we just have like two input like to a vector size 2 embedding, then we don't have that flexibility. Okay, what is the like apple? It can be apple the company, apple the fruit. We don't have like that much space to introduce this semantics. So that's also my intuition of why is that we build long sequences.
Because if we take in isolation an word and its mathematical multidimensional representation, by itself, this multidimensional representation says nothing about that particular word. Yeah? But if you model a second object, then you can see how related are these two words, just looking on the mathematical representation of each one along different dimensions.
I have a side question. Since the models are multilingual, how does this work with multiple languages?
I think my intuition here is that there is an additional layer which performs translations to a common and universal language, probably English. Because the object which is described by a word, so a word is a semantic representation of an object or of a situation, and you can represent that object in different ways in different languages, but all the representations in different languages describe the same object. So it's just a matter of translation, I would say.
Yeah, I want to make a question about this. To actually understand the embeddings, I believe that we need to have the models, and that's something difficult because I guess when you consider things like, or when the model, the LLM considers words like Madrid or Paris, it will find these words in many contexts. Sometimes it will be something easy and very similar, like Madrid is the capital of Spain, Paris is the capital of France. So it will when the model sees these kind of things, I can kind of understand that the embeddings some part of the embeddings, especially if they are big, as Santiago said, some parts are going to get moved in similar directions. Or we're going to get closer in some senses, and then it's going to find other words that are also similar. Like it will find Madrid is a city from Spain, but also Barcelona is a city from Spain. So it's going to get closer also Madrid to Barcelona. And it's kind of a geometrical thing. But for me to understand this, I want to make a question to more experienced people. Does this get accomplished by training only the embedding layers on models that already have seen these things and already know sentences and already have seen sentences like Madrid is the capital of Spain and all of that? Because otherwise, if you are training all of the parameters at the same time, I don't understand, and the model sees sentences like these ones, it can change something on the transformer rather than going back to the embedding. So I guess this, what you do is you freeze the other layers to create a model that only embeds, maybe.
I'm gonna share what I understand. So let's say if you're working with a pre-trained model, one that has already seen lots of internet text, then yeah, then it doesn't make that much sense to continue optimizing on the embedding layer because it already has an understanding of the general words, and you just want to like freeze that part and optimize the last layers. But I will guess in the following chapters, we will we will pre-train these embeddings that right now they are just random numbers. They actually don't mean anything yet until we get them data. But yeah, this relationship is it's learned by just this ton of data, and I guess that's the heavy part to construct embeddings that are like high quality, and that's why you need like lots of data so they can look at different how the word plays in different roles.
Yeah, if I may, Carlos, I think your question hits to the core motivation of why all of us are going through this entire book. That ultimately that understanding, that learning, we're only looking at like, okay, well, here's a sentence and what is the context of the words in this sentence to the words around it and so on and so forth. But when you expand this out, the model really begins that learning that it does isn't just the order of the words that makes sense, but also um, the knowledge of the world as a world model would have. Recognizing Barcelona and Madrid are cities in Spain and the distance between them and so on. It's like everything that would normally be in our human heads, human brains too. And how that comes together, how that's built up, I think hopefully we'll have a better intuition of it by the time we're done with this book. Again, your question is the motivating reason for this effort.
Yeah, I also had along these lines, I had the same kind of question. What does it mean to
Hi, can you hear me?
Yeah.
Yeah, okay. So
Yes, but wait, because Eddie was asking something.
yeah, so I was wondering also, where is the distinction, the separation between, let's say, the fine-tuning process where you tell to the large language model all these different situations where Madrid and Paris can exist, and the embedding part of the model. So because we assume, or at least I assume that within this tuning, within this fine-tuning, or within this pre-tuning of the model acquires this, let's say, understanding. But now we have also this embedding layer of the architecture, and what exactly is its role within the overall architecture of the embedding layer? I mean, in terms of training, or is anybody which has a little bit more deeper understanding of this? The role of this embedding layer.
The embedding. So as we see here in this specific picture, we have the embedding is basically like matrix where we have like it was initialized randomly. And during pre-training is that we are like tweaking these weights inside this matrix. So based on like we're minimizing a loss. Well, pre-training, there's like lots of text. We are trying to do like next word prediction, right? And while doing that, we fail. So then we change, adapt a little bit this weight, try it again. We fail a little bit less, and so on until like we are happy and our loss is minimized, ideally. And the crazy thing is that minimizing a function leads us to good embeddings, to embeddings that actually can represent some sort of meaning. And that's the role of the embeddings. Of course, during that process, a lot of other weights and get optimized from other matrices that we're gonna see. But basically, that thanks to backpropagation, we're able to like tune these weights in a great way.
So basically,
Yes.
it's a standard. Let's say, to put it in simple words, it's a standard neural network with backpropagation, which has its own life cycle, if you want. Yeah.
Yeah.
Yeah, so I was going to say that these embeddings are not only limited to basically transformers or LLMs. So basically, I have seen something called entity embedding in when trying to work with tabular data. And there is a great notebook from fast.ai, which I'm going to share, and you can put it up on your screen if you want. So basically, what
Screen share if you want. You can take the screen if you want.
no, it's okay. So basically, there's one figure that I want to, draw your attention towards. So if you can open up that link. So basically, what it says that when there is a competition, there was a competition Kaggle on Kaggle, way before, like 7, 8 years before, and then they trained a neural network to predict the cells. Okay, that's just task. Okay, so given some locations, given past figures of cells in a medicine chain, so they just wanted to predict what are the future cells going to be. So basically, they trained this model, and yeah, this figure that I want to draw your attention. No, below, the one with the map of Germany. Yeah. So basically, this is the left is the embedding space, and right is basically the map of Germany. Even though the model that was trained or the data that was given, there were no information regarding GPS or any type of geolocation. Okay, so basically when the embedding layer was inspected, it was seen that it can learn the map of Germany without any explicit information about location. Okay, so that's pretty cool. So this is called entity embedding, and basically you can see the architecture one page up. So they just trained this network and they got this embedding space, and you can just see that it basically learns a pretty rough map of Germany without explicit network location information.
Brilliant share,
Yeah.
Sri, because it also highlights that multimodal, it's not just all text. This coding approach, as long as you can put it into numeric tensor or vector form, you can do all sorts of applications.
And there is another graph that is another page below. So it's basically learns which days are after which days. So basically the ordering of days in a week without any explicit training data. Yeah, in the embedding space.
How does it understand the order without training data based on the embedded? Like, what is it? What's being embedded? What's encoded that helps it understand the
So, okay. So I read this many years before, like 3 or 4 years ago. And if you go to the text, it explains this kind of intuitively. But what the key was basically these are medicine chains, and real people are going to buy medicines. So basically, when there is a flu season, medicine purchasing increases. When there is like basically mild season, there are no low amount of diseases in population, so it decreases. Or maybe people maybe want to go to a medicine shop in weekends, basically, or middle of the week. So these are the intuitively you can think it like this.
Cool. Yeah, and as you, I don't know if we lost Sri, but Sri got some. But it takes in all sorts of data,
Yeah. But
embedding.
there are no, yeah.
Mhm.
But there are no explicit location information, for example, GPS or anything like that,
Mhm.
or LATs longs were not shared. So these are the embeddings that were learned, and this is end-to-end training. So we are not leaving it at the embeddings. We are basically trying to find a logistic loss, and then try and predict what is going to be the future cells. And this actual implementation were among the top ones and on the gold medal. So when you inspect back the embeddings, you can see those, and these only work with categorical features.
Mhm.
And so, for example, the real numbers ones like age, app installs, these don't embeddings weren't there put there, but categorical features were used.
Yeah, I remember. I think I
Uh,
remember. In 2018, 2019, I remember struggling with this notion of how is it that these embeddings and then going through these activation layers
Mhm.
would help build a training that philosophically understood things better. I mean, this was me at that time coming from the data science, machine learning methods where
Mhm.
I trained data that where it was pretty clear what the predict value would
Mhm.
be, what
Mhm.
class, and so on. But this approach, now I'm like recalling, geez, I don't think I ever sorted it out in my head. Like philosophically, I think Eddie, this gets to your point. How does it really understand and learn the order of things, the ground truth, if you would?
Yeah. And these are not text data. Like there aren't any information that says like this person went to the shop on Sunday or something like that. Just tables and data.
mhm. Very cool.
And
One, yeah,
Yeah, just one thing I wanted to add quickly. So
please go ahead.
basically,
Yeah.
you can work with like any sorts of embeddings. Like can be like picture and words. It can be picture and video, or words and video, or anything like that. So basically, if you train it end to end, it's gonna work. So just like we can see with something like Clip, OpenAI Clip. Anybody remembers it? It's like pretty old, you know. So Clip basically does is it has word embeddings. It also has like picture embeddings. So if you train a model, if you want to train a model, like if you want to train an image generation model or image captioning model, you can use a Clip as sort of in the middle. So that basically bridges the two domains of picture and language, and you can train the comparison embeddings to achieve the task that you are trying to do.
Interesting. Wouldn't it be wild if this is all the core understanding that goes into building better and better foundation models from OpenAI, that all they're doing with all the incredible capabilities that they're unlocking, as well as like Anthropic and others, are just implementations of this same thing. And it's not like they're trying to figure out the philosophy behind it. They're just regurgitating and expanding this out, throwing more and more powerful compute at it.
I think there are multiple levels of analysis here, and Definitely, this is one of them, what you mentioned, but also I think there are some deep thinkers, say in companies like OpenAI and others, which go to the bottom of things. You have to go to the bottom of things in order to create, let's say, a mathematical model, which is then implemented through neural networks, etc., which is able to understand, like a human, what is an apple, yeah, or what is, I don't know, an orange. So you need to reach a certain level of understanding of what, for example, the word meaning is. Yeah, it's not trivial. I mean, there are a lot of very smart people which try to dissect the word meaning. I mean, the word meaning, it's super complicated, at least for me. The word meaning, what means what it is the meaning of words. So this is, I think, is the starting level for all these, let's say, deployments of large language model from a very
I
deep
just have a
understanding.
perspective to add on that. Sorry. Eddie,
Yeah,
you
please.
complete
Yeah.
yours? Yeah. Yeah, because I mean, if we stand at this point of time and we ask what is meaning really, I mean, it's a tough question there. So for me, I mean, that's why I wanted to add the perspective, and probably it will be helpful for to beginners or also someone like me, like a few months before, even I was grappling with the question, what is meaning? I think it's instructive to look at the history of this and how the challenge of language, how it evolved over time. That, if you take the classic challenge of, we want to translate a text in German to English, for example, there. Now, the most initial part, they started with, can we have some rules, grammar rules there? Then they figured, okay, it doesn't work there. Then they did something like one hot encoding. Okay, can we take a word, create a dictionary and give a word, 0100? Then they figured that it's computationally hugely challenging that, for every word to have a sparse vector there. Then they tried something like, bag of words. There, can we have like, frequency kind of thing there? Then they tried, TF-IDF, can we have this? Okay, it's not just word, frequency. Can we have some, actually information? The rarer the word, it has more information. That's the next step that happened. Then we have, word to vec and glove. I mean, after all these, I mean, there's a lot of efforts that happened. Then we came on to something like word to vec and glove, which said, okay, I think the Google folks, someone did it. Their embeddings can capture a lot more meaning than before. There. Now, after word to vec and glove, then we had, RNN, LSTM. Those networks look like, can we capture, some kind of meaning in a sentence so that we can translate it better? But even that had limitations there. So next then came, where we are right now is in attention, all this kind of attention and transformers where we are. So it has been a long journey of, of progress and challenges to be able to just translate a text, So we may never reach, 100% meaningness and there, but we are able to capture a lot more meaning than before. And for me, it made sense to look at, okay, this is a history that happened just to be able to, understand how language, to be able to capture more meaning through language. And sometimes that's not presented there. We just got a snapshot of where we are starting from token and embeddings there. But there's a lot more history of progress and failures and there which helped us reach where we are. So it just helps to have a sense of that. They just wanted to share that perspective. Yeah.
Yeah, I fully agree with you, Naveen. I mean, I understand. I know the history of all these challenges, but also I am also coming from, let's say, from more, if you want, a philosophical approach, because let's say there are multiple levels of reading. Yeah, so like a neural network is able to read something, yeah, in all its variants, RNN, LSTM, etc. So is able to read something, and as you said, the performance was not very good. So and now we have this attention mechanism and everything improved. So I can correlate this history. I can correlate this history with the levels of reading. I will share a very interesting link here. Which are the levels of reading? Yeah, there are multiple levels of reading, which I think that nicely map to the history of the understanding of the language by the AI solutions in general. Yeah, so right now I would say that a large language model is at the first level, which is syntopical reading. If you go to the first level, so first one is elementary reading, then the second one is inspectional, which goes a little bit deeper. Then the third one is analytical reading, and this is how we read a text. Yeah, and the first one, which is the deepest one, is syntopical reading. So this is what an OpenAI or a similar solution does, in my opinion, is able to take a very complex and systematic approach of the language. Yeah, so that's why I'm trying somehow to come from this, let's say, a little bit philosophical angle to better to have, let's say, more nuanced understanding of at least for the intuition.
Santiago, I know you have a point. If I just can add
Yeah,
5 seconds. Naveen and Eddie, just for me, thinking like a consultant, there's a common thread in this journey that we've been doing as all the way from like iteratively building up from different neural network frameworks and approaches to then using the transformer architecture for attention mechanism that ultimately elaborates or enables what Eddie just described, different types of reasoning and understanding, right? How we read and how we synthesize this knowledge. There's a common thread there. And that common thread builds on how we do this encoding, decoding, and how we structure knowledge. Is that common thread the right and true one? Or is there another? What if somebody were to take an entirely different perspective and say, you know what, we're going to go back to the drawing board and we're going to start to take knowledge in an entirely new and different way, whether that be applying entirely new mathematics. And I'm making this bit up. I mean, it could be non-binary form, quantum methods, or so on. Come up with a different understanding of knowledge. Maybe that could help us build models that understand information a lot better, more closely resembling perhaps the human mind. But again, getting perhaps a little too philosophical. Santiago, I'm sorry. Sorry.
No. It was good just to also close. Like it was good that you gave the comment to also close a little bit because I know that we like deviate a little bit. So just to get back on track because we are at 20 minutes from the hour. So maybe I don't know if we should check regarding this specific chapter, if there's something that we're missing that we should bring next week, or if there's any specific questions regarding this. Yeah.
If I haven't explained any part of this chapter, please let me know. I can come back and we'll continue next week until everyone's
Maybe,
comfortable.
yeah, I think from my perspective, I think we cover embeddings quite nicely. Maybe the only thing from this chapter that is still like tricky and important are positional embeddings that we didn't mention
Yeah,
them and their
and
role.
for me
Yeah.
as well. Yeah.
I don't know if someone,
Yeah,
somebody.
which exactly is what I want to say about the position of the words, which also probably will lead to the same kind of analysis. How do you know that, or how an embedding algorithm knows that one word has a more importance than other? So,
Yeah. All right, we can come. Should we continue, or do we? Since we've gone way past the hour, would we like to come back to this for a bit next week, and then allow maybe someone else, whoever is eager. Remember, no one among us is as smart as all of us. So love all this discussion. If somebody wants to take the next chapter 3, but we can continue. Tell me if you guys want to come back to positional embeddings and try to close this out before somebody else picks up next week with. And Santiago, I think we may need a little bit more than an hour, even if we go at the pace like this. No
Maybe.
sound get right into it, we might need 90 minutes at least.
Yeah, I would say 90 minutes at least. So maybe in the next session we'll put it as 90
Yeah.
minutes. Yeah. Because I think we like next chapters are gonna be even like they're gonna bring even more discussion. So I think
Yeah,
90
and
minutes.
probably the next chapter, which is attention and transform, which is one of the most important concepts. Probably we may need to split across 2 sessions. Maybe
Probably
if
yes.
the magic folks can take a call, because I mean there are a lot of nuances to that. I mean, it feels like we like understood it, but we really don't understand it. So it's good to have the discussion and expose our understanding and misunderstandings.
Yeah.
Okay. All right. The next week I'll keep going with the positional embeddings, try to explain that a little bit more deeper. So who wants to take attention mechanism? Please don't make me do it. Or Santiago.
I will do it.
Okay.
I will do it, but probably we'll need at least 2 sessions because it's a super important topic, and I'm not sure if I will be able to cover it at the level you expect. And yeah, so I will take it now. Chapter number
Thanks,
2
Eddie.
in 2
Thanks.
weeks. In 2 weeks.
Okay.
To have some time
So
to prepare. Yeah.
Eddie, you're not in it alone. We'll all help you.
Okay, super. Thanks.
And I'll
yeah.
connect how I can bridge from positional encodings over to you on tension mechanisms, and we'll just
Yeah,
do
I'll probably send you a message or a LinkedIn request or something like that if I can find you. I just wrote your name, Eddie. So if during the week you would like to chat or you would like to organize something, maybe Mash or I can meet and discuss.
Yeah, sure. I will make a draft and I will ask for you to review it and yeah.
Pretty
That's
cool.
yeah, Eddie. That's exactly how Santiago and I as well.
So do you want to take the both 2 weeks or you want to split it with somebody?
That can also works.
Yeah, I will start. So in 2 weeks, which will be on 2 weeks would be 1st of December. Yeah, I will start with attention mechanism, and yeah, of course, it's also an option somebody to also to have
Like the second part.
a second part or a different perspective, basically, because I think it's a very complex topic, attention, and at multiple levels, it's a very complex topic, and I'm sure that everybody might have his own, interpretation on the approach to tackle this topic. So, well, if somebody wants to take or to have to show or to present a second perspective, it's fine.
Why don't we
Santiago?
play by?
Yeah, sorry.
No, Santiago, just to be clear, Santiago and Eddie. So next week, I continue with positional encodings. It shouldn't take hopefully too long, 5, 10, 15 minutes max or so. Wrap that up. And then Eddie, that's where you then go into transformer architecture, chapter 3. Let's go through Sebastian's code and notebook, but we expect it's not going to be enough. Even next week, as we get through 90 minutes, we're going to all have a lot of questions. We're going to have a vigorous discussion, which will, after the 90-minute mark, will let continue into the week after.
Correct.
Right?
Yeah.
But go ahead, Santiago.
No, that someone asked exactly what do we mean by 2 weeks in the chat. So yeah, that basically next week we'll meet again. Mash is gonna finish his interpretation of positional embeddings, and then Eddie is gonna take off. Is gonna take attention, and that will probably take 2 weeks, and probably somebody else will help Eddie in the second week. Yeah. Just to summarize. Yeah, that's, I don't know, Mash, do you have anything else?
No.
I think we have next week's lecture. That's great. And well, so I wanted to discuss something. Someone asked on Discord that they cannot use Zoom for, I don't know why. That is very weird for me. I don't know if we should use another tool or not. What are your thoughts?
Zoom might be blocked in certain countries, but yeah, Google Meet works really well too.
The thing is that it doesn't have like, well, right now we were like 42 at the max, our like largest audience today, but I think it has like an attended limit, capacity limit of
Yeah, and
participants.
recording as well, because we're going to be sharing this recording on YouTube.
Yes, yeah, yeah. And right now I'm using like a Zoom paid plan by my company, but yeah.
Yeah, I
So
think you can stop the recording for today, I think.
yeah, that's true.